So one more time. Unit 1, exponents, day 3. Today we are going to talk about negative exponents and dividing exponents. It's still going to be important that we know exponent form and expanded form. Expanded form is going to come in handy today. Now, Grego asked a great question. How do I know when I'm done simplifying? So, let's say simplify. Okay? First, a number to a power is not simplified. So an example, if I give you 3 squared, this is not simplified. So if I ask you on a quiz to simplify and you leave me 3 squared, that is wrong. It would need to be 9. Let's change colors. Any 0 exponents are not simplified. So anytime that you have a 0 as an exponent and you give that to me as an answer, it's not simplified. So if you give me 3x to the 0 as an answer, that's not right because it's really 3 times 1, which is really 3. Okay, so far, we know we have to simplify the power, or a number to a power. We know we have to simplify the zeros. Now we're going to talk about today. So this is still about simplifying. It is not simplified if there are any negative exponents. If I ask you to simplify and there is a negative exponent in your answer, you are not done. Okay? So far we've only seen positive exponents, 2. Well, today we're going to see negative 2. And that's going to cause us to have to do something else. 3 to the negative 2 is not simplified. X to the negative 2 is not simplified. Last but not least, when simplified, there can be only one of each variable. There can only be one of each variable. So if you give me an answer that says 3x squared x to the third, that's not simplified. You need to combine your x's. There can only be one x, there can only be one y, there can only be one z, there can only be one t. Whatever the variable is, there can only be one of them. Everybody with me? Yeah. Okay. So have that copied down, and then we will talk about division. If you can't see, let me know, and then we'll keep trying to adjust. Okay? Just don't bump the camera. Thank you very much, Mason. Okay, division. First off, watch what I'm going to do here. You've seen fractions before. Go that way. So you go. Stop. You can't be in the camera. Whew, that was close. Go that way. Whew. I'd have had to start all over, and I'm teaching so well right now. Come on now. So, a fraction truly is a division problem. So if you see the fraction of 7 over 7, that means 7 divided by 7. What is any number divided by itself?
1.
Megan? 1. 7 divided by 7 is 1. What if I say x divided by x? Wait. Say it. 1. A variable takes the place of a number. So x is really a number. We just don't know it. It's an unknown value. So this value divided by itself is still 1. Everybody with me? Well, what if I gave you x times x times x divided by 1x? Wait. Just write it down first. And then, David, I'm going to get you. Okay? Because I think you've got it. I think you've got it. Can we see it on there? Let's move this just a little bit. There we go. So, David, talk me through the process. What am I going to do?
We'll multiply the 3 x's, I guess.
You could. I like that you could multiply the 3 x's. Not what I want to start with yet. Michaela?
You put an exponent.
We could put an exponent. Guys, I like what you're thinking. You're thinking too far. Okay? Mrs. Armstrong? B? B, what do you think?
I think you just multiply all the x's to put it.
Okay. So you guys are trying to put it into exponent form. I don't want to yet. Watch what I'm going to do here. Let's break this down even more. Let's just look at that x divided by x. What is that? What is x divided by x? 1. What is 1 times anything?
1.
The anything, right? If I do 1 times 7, it's 7. 1 times a million, it's a million. These x's, and I'm going to use a word that will make sense to you, but I'm not going to use it after this. They cancel. Well, they don't cancel. What happens? X divided by x becomes 1. So this x divided by this x is really 1. What's 1 times x? X. What's x times x? Now we can make it into exponent form. What are we left over with? X to the second. Oh. Huh. Okay. Let's make it a little bit more like you usually see it. Let's say we've got x to the third divided by x to the fifth. Okay, remember how you guys gave me rules before? You're going to give me the rules here as well. Let's expand it first. So Abby, x to the third is going to be written as what? If I want to expand it. How many different x's? Yeah, there's going to be 8 total. There's going to be 3 in the top, x times x times x, divided by, there's 5 in the bottom, so I'm going to say x times x times x times x times x. Everybody with me? So there's a 3 in the top, 5 in the denominator. Numerator, denominator, right? So let's group them together. What is this x divided by x? 1. So now I've got 1 times. What is this x divided by x? 1. So they're not going away, they're just becoming 1. What is this third set that matches up?
1.
Oh, when they divide, they're 1. So now I have 1 times 1. Do I have anything else in the numerator?
No.
So what's 1 times 1 times 1?
1.
What have I left over in the denominator?
2 x's.
Which is
X to the second power.
x to the second power. Oh my goodness. Wait a minute. Let's take a look. I had x to the third in the top. I had x to the fifth in the bottom. And we got 1 over x to the second. Yes, ma'am. It wouldn't be negative. That's the answer right there, sir.
I was going to say something.
Okay.
So last year when Mr. Moore was here, we had these like tiles, and the
Mhm.
red side was negative and the yellow was positive.
Okay.
And we would have to group negative and a positive together to make it cancel out and be 0.
Right. That's a little bit different than what we're doing now. We're going to do that with equations. Okay? Because this isn't canceling out to become 0, and we don't use cancel. They added together to become 0. These are dividing out to become 1. It's the same idea. Okay? So, let's do a couple more examples. Let's see if you guys can figure out a rule. Because I don't want to have to keep expanding these numbers out. Let's say I've got x to the 9th over x to the 3rd. Man, I don't want to expand out x to the 9th over x to the 3rd. Oh, well, let's see what happens. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Everybody still with me? Pencil sharpener, next room. I've got these x's that are dividing out, correct? What happens when these 3 x's divide with these 3 x's? They divide out to become 1. They divide out to become 1. What am I left over with?
6 x's.
6 x's, which leaves me with x to the,
6th power.
Which is 1.
okay, so it leaves me x to the 6th power. Is somebody starting to see a little bit of a pattern here? Yes, ma'am?
So if it's on the top and it has more, it's just, it's not a fraction, but if it's on the bottom, it is.
Well, it could still be a fraction because it's dividing by 1. Any whole number is always dividing by 1. So I could put that, but you're right. If it's bigger on the top, I'm not going to necessarily have it dividing by 1. Mrs. Armstrong?
I'll see what it says.
David?
I was going to say, any leftover number that can't be paired to make 1 will be a part of an exponent.
Very good. Any number that can't be paired is going to be left over. Well, what does left over mean? Which mathematical operation is left over? Maddie?
Remainder.
Remainder, but what are we doing? What operation? Add, subtract, multiply, divide.
When we
We're subtracting. What's 9 minus 3? What was 5 minus 3? Where was the bigger number, 5 or 3? Where was the bigger number? In the numerator, which is the top, or the denominator, the bottom? Oh, man. So let's try this. Let's say I've got x to the 47th divided by x to the 12th. I do not want to write out 47 x's. I don't even want to write out 12 x's. So here's what you need to think. Which numerator or denominator do I have a bigger exponent? Carly, where's my bigger exponent? Numerator, denominator? Numerator. Okay, so I'm going to still put a fraction bar because you're right. I should have been doing that the whole time. I'm sorry. I should have been making that clear. What do I do now to find out what the numerator is? Go ahead.
Subtract 47 from 12.
Oh, man. Go ahead. Which is?
35.
Which is 35. So that gives me x to the 35th. Well, what happened to this x to the 12th? It divided out, right? To become?
1.
Could you put this? Absolutely. But when we divide by 1, we also know that it's just x to the 35th. Both of those would be fine. Still with me? Okay. Let's make it this much harder. This much harder. X to the 8th, y to the 3rd. X to the 4th, y to the 7th. Let's just think about the x's. Let's just think about the x's. Brooklyn, is this already a fraction? Yeah, so let's put the fraction mark. Okay, I love that you told me that. I needed to do that. It's going to make things much easier. Thank you. So Brooklyn, it's a fraction, right? Where's my bigger exponent for my x's? In the numerator. So guess where I put my x? In the numerator. What do I do with my exponents now? What do we do with those exponents? Go ahead. subtract them. We're just talking about the x's, so I'm going to do 8 minus 4, which is 4. We've done these now. So I'm going to switch colors so you can see it a little bit. So let's deal with the y's. Mr. Alisi, where's my bigger exponent for the y's?
7.
Which is numerator or denominator?
The numerator. I mean denominator.
Denominator. Down, denominator. So I put my base of y down there. What do we do with those exponents now? Sammy, do you know?
Then you subtract them.
You subtract them. 7 minus 3 is?
4.
Notice in this problem here, I had an x here, I had an x there. That's not simplified because how many variables can we have? Just one of them. I erased that already, that's too bad. So this is simplified. I can do nothing else to it. Yes, ma'am?
If this y's were reversed, like the 7
Mhm.
was on the numerator, would it just be x to the 8th and 7 to the 4th?
It would be x to the 4th, y to the 4th over 1.
What is this? Yeah.
Okay? Let's make it a little bit tougher.
There's so much.
12 x to the 3rd y. 4 x y to the 8th. Okay, so now take a second and let's remember first off just what a fraction is. A fraction is a division problem. Can we simplify 12 divided by 4? Yes, David, what is 12 divided by 4? 3. So I was already told, hey, Mr. H, why aren't you putting that fraction bar? I need to. Where does 3 go? The numerator or the denominator? The numerator. So we've already taken care of this. Now, what are we missing on some of my variables? Come on, I need some more hands. Maya.
1.
Ones. Where am I missing a 1?
The x and the y.
The x and the y. Every variable has to have an exponent. Where's my bigger exponent for x? Where's my bigger value for x? Brooklyn? In the numerator, so I put my x there. So now we're just focused with the 3 and the 1. Swill, what do I do with the exponents now?
Subtract them.
Subtract them. What's 3 minus 1?
2.
2. Where is my exponent bigger with the y, Chris, in the numerator or the denominator? We'll take a guess. You got the numerator, you got the denominator.
I don't know.
Okay, well, guess. N or D?
Yeah,
D, the denominator. The denominator is where my bigger exponent is. So we keep the y down there. Garrett, what do I do with my exponents now?
You're gonna add them or subtract them?
No.
Subtract, good. So we have 8, we have 1, we do 8 minus 1, which is 7. 3 is simplified. There's only one x, there's only one y. We're good there. Questions? I'm letting you know right now, because we haven't even finished, you will have a quiz on Friday. You will have a quiz on Friday, not on Thursday. We're going to break this lesson into 2 parts. We're going to do division today. We'll do negative exponents tomorrow. So, here's what you're going to do. You are going to work with your groups. I'm going to put a couple other examples up there. I'm going to keep these 2 examples on the video. That way you have it, and then we're going to give you some classwork, okay? So, let's do this. Just 2 to start. So the first example, so example 1, let's go 3 to the 3rd. We're going to make it a little bit trickier. X to the 4th, y, z to the 7th, over 3, x to the 5th, y, z. And example 2, 6 over 9, x to the third y, x, y to the 18th. Try those two problems. Go ahead, write them down and give them a try. Yes, ma'am.
Since it's 3 to the power, you just change it to like 7.
You could, or you could. They have like bases. So what could we do with the exponents? And then subtract, and then simplify from there. But either way you want to do it. That's why I put it up there. I want to see.
It's not hard, you just don't want to have good numbers.
Yes, ma'am. Exactly. And then it's like, okay, good. Say it again. Oh, what happens when 1 minus 1? Yeah, I made them a little bit tougher. You got it. I made them a little bit tougher. Okay, so some of you are making great progress, some of you are struggling a little bit, and I expected you to struggle. I tried to throw some things out to you that you would have trouble with. I want you to see the hard stuff so that when you see the easy stuff, you're like, wow, this is really, really easy. This isn't hard at all. So, couple different ways in example 1. You can simplify 3 cubed divided by 3 first. Andy, I need you to keep your head up, buddy. So sit up. All the way. Thank you. Okay? So, we need to put exponents with all of our numbers and our variables. 3 to the first, y to the first, y to the first, z to the first. Then we put our fraction bar. 3 to the third, 3. Those have like bases. Where's my bigger exponent? Top or bottom? Top in my numerator. So 3 minus 1 gives me 2. Where's my bigger x? Numerator or denominator, Mr. Alisi?
The numerator. I mean denominator.
Which one do you mean?
The bottom.
The bottom, the denominator. 5 is bigger than 4, so my x is going to stay down here. 5 minus 4 is 1. This is where we got stuck. Y to the first divided by y to the first. Well, what's y divided by y? Just 1. So 1 minus 1 is 0. Y to the 0 power, though, is 1. So where am I going to put times 1? In both the numerator and the denominator. And I'm going to show you why in a second, because anything times 1 is that anything. So this is gone, this is gone. Now we're talking about the z's. B, where's the bigger z? Numerator or denominator?
Numerator.
Numerator. So I put times z. I subtract 7 minus 1 is 6. So let's start simplifying. 3 squared is 9 times 1 times z to the 6th over x to the first times 1. We done? Not quite. What's 9 times 1? 9 z to the 6th. What's x times 1? Just x. That is my problem simplified. That is my problem simplified. Okay, I would copy that down. Almost lost that. Let's see if your calculator's on here. You guys might actually be able to help me out with your calculators. These calculators will simplify. So, for example number 2, we need to start. Do we have like bases with a 6 and a 9? No, but those are numbers. Can we divide 6 by 9? Yeah, so let's just put 6 divided by 9 in our calculator. It gives me 0.6666666666, and it keeps repeating forever. Okay, it's a repeating decimal. We don't want decimals. We want to simplify 6 divided by 9. So in your yellow calculator, look to where it says n divided by d. So get your calculators, take a look. It's in the second row. Go down 3 buttons. You'll see n divided by d. Does everybody see that button? Put 6, press the n divided by d, press 9, press enter. Okay? Oh, gee, what'd you get?
She messed up.
Okay, let's do it again. So, we're going to press 6, the n divided by b button, the 9, we press enter. So what do we end up with?
2/3.
2/3. So, you take that, that's yours. Sorry. 2/3. So now, I'm going to put my equal. If 2/3, same idea, it's a fraction. That's what 6 divided by 9 simplifies to. You have to simplify that. Now we've got our x's. But one of our x's needs an exponent. One of our y's needs an exponent. Bianca, numerator or denominator? Where's my bigger x? The numerator. So my x stays. We do 3 minus 1, which is 2. Then we have y's. Then we have the y's. Where's my bigger y at, OG? Numerator, denominator. Denominator, so I put my y. 18 minus 1 is 17. And that's it. Okay? So, you have homework, and I'm going to leave this on the recording because I had this worksheet all printed out, copied for you, I was ready for you, and then I realized that we weren't going to get to negative exponents at all today. So, you're going to have to copy down 2 problems. This is homework. Okay? So you're going to need to work on it. I started in class because it's 2 problems and you can finish it up. So, here's your 2 problems. Number 1. 4 to the 4th, x to the 9th, z to the 2nd, a cubed b. All divided by 4 to the 5th, x, z, a, b to the 7th. Number 2. 12, x to the 5th, y to the 3rd, z divided by 20, x to the 3rd, y to the 19th, a, z to the 3rd. Copy those 2 problems down. This is your homework. I will be checking this. This will be your second grade for the 9 weeks. Watch the video if you need help. Yeah.